We'll have a look at another method we can use to find our most probable position when we are inside the cocked hat. And remember, inside is when the azimuth bearings apart exceed 180 degrees. So for example, from 282 degrees all the way around to 159, whichever way you want to look at it, these will exceed 180 degrees. So that's where we have to exceed the value there. So we're given our stars, and you'll notice our DR is 1823 and we have different times. So just a little sketch here will show you what we have to do. Our course is 288 and stars A and B are observed before 1823. So if they're observed before, we plot after. Observed after 1823, we plot before. So we have to work out the distance the ship will have run in that time and move the star to the relevant position on the course line that we draw for our plot. And remember, if it's zenith distances with true tiny towards as opposed to altitudes, which would be the opposite, of course. So we end up with our bearing and intercept. So we do, first of all, we do the plot. And there you see there's our course of 288, star A, B and C, and we've got our 3 position lines. So that gives us a cocked hat. Now for this particular method, we simply draw lines 1 mile away around inside or outside the cocked hat. So distance 1 mile, 1 mile, 1 mile, then draw from there through, and through, and that will give us our ship's position. So it's quite straightforward. You could have put those lines inside and drawn, but you'd end up with the same position. And then if you want the systematic error, you simply put your compass on and draw round and then measure the distance, and that will be the systematic error. So that's another method of finding our most probable position inside the cocked hat.